In this video, we'll be exploring how to find the distance between a point and a line. But what exactly do we mean by the distance between the point and a line? Because a line has an infinite amount of points. And so how do we know the distance? Well, imagine if we have a segment joining our point B and an arbitrary point on our line in orange. Well, is the length of that line considered to be the distance between the point B and our line? Well, in reality, it is not. Because when we're talking about distances, what we're really referring to is the shortest distance between our point and our line. And what is that shortest distance? Well, imagine we have a point P on our line. And that point P is not arbitrary. It's placed on the line such that the line joining these 2 points, joining our point B and our point P, is perpendicular to our orange line, so to our initial line. And the distance, the shortest distance, is actually the length of the segment joining these 2 points. And visually we can see that the length of the segment BP is shorter than the blue segment over here. And so the segment that is associated with the line that is perpendicular to our orange line will always be the shortest distance between the point and the line. Now that we got that out of the way, we need to determine the distance, the value of the distance. And the way we do that is by working with vectors. And remember, whenever we are talking about lines, we need to consider the equation of the line in terms of vectors. So every point on the line can be described or associated with a position vector. And we will say that that position vector is arbitrary. So the point is arbitrary, and we will call that position vector R. Likewise, we have a position vector associated with our point B, and we will call that position vector lowercase b. Now, it's important to note that whenever we're considering distances, we need to think about doing a difference between 2 objects. So in this case, we need to consider the difference between our position vector R and our vector B. Even though this difference does not give us the distance, so the shortest distance between a point and a line, it's important to really think about differences whenever we're talking about distances. So we have a difference between these 2 vectors. And visually, what does this difference represent? Well, it represents this vector over here. So the vector that is joining the endpoints of vector R and vector B. The way we know that the resulting vector will be in this direction over here is that, first of all, let's call the difference vector C. And if we bring our position vector R on the other side of the equation, we will have vector R plus vector C. And clearly the addition will result in our vector B. This graph is a bit confusing because it might seem that our position vector B over here is perpendicular to our orange line here. But we want to consider the general case. So our vector associated with our point might not be perpendicular. Therefore, I will change the position of our point B. Now, clearly we can see that our vector B over here is not perpendicular to the line. And so now what we need to do is find the shortest distance. Now we know that our difference vector will be in this direction. And since our vector R represents any point on our line, we need to choose our vector R at such a point that lies directly perpendicular to that point and our point B. In other words, since R represents any point, we need to adjust it, and therefore we need to find the point such that the resulting difference vector will be perpendicular to our line. And the reason we considered the difference vector over here is because it joins any point on our line and our point B over here. And so since we need to find the line joining point B and a specific point on our line so that it's perpendicular to that orange line, well, we need to consider the difference vector. To better understand what I mean, imagine if we have our point P here, such that the line joining point B and P is perpendicular to our orange line. Well, we know that since our point P lies on our orange line, well, we have an associated position vector which we will call R prime. And what we realize is that the resulting difference vector will actually be parallel to the line to the perpendicular line. So first, let's call the new difference vector C prime. And if we draw out a line that is perpendicular to our orange line, we notice that our vector C prime is parallel to that red line. And so if we manage to find our vector C prime, the only thing that's left to do is find its length. And if we have its length, we get the shortest distance between the point and our line. Because remember, our vector C prime is perpendicular to our orange line, and therefore it's associated with the shortest distance between our point B and our line. In the next video, we will show how we can calculate that distance. But in this video, I just wanted to show the idea behind the way we can find the distance between the point and the line. So in a nutshell, what we have shown in this video is that to find the shortest distance between a point and a line, what we first need to consider is the difference between the vector B associated with our point and the vector R, which is related to any point on our line. And if that the difference vector is perpendicular to our line over here, then we have found the vector which is associated with that distance. And if we can find the length of that vector, then we found the distance between the point and the line. And so essentially what we will be doing in the next video is determining the vector R prime such that this distance vector over here is perpendicular to our line. I realized that this video was more conceptual, and in my next video I will be more specific and straightforward with how we can find the distance. So thank you for watching this video. If you have any questions, of course, leave a comment down below, and if you enjoyed it, don't hesitate to drop the like button.